So for number 8, we are being asked to find the value of cosine of tangent inverse of 5/12 minus sine inverse of -3/5. All right, so right off the bat, this is going to feel like a lot of information to process. And you'll notice that while I am going through this problem, I'm going to really not try and bite off more than I can chew all at once. I really focus on kind of breaking this apart into a bunch of kind of smaller pieces and dealing with each of those pieces individually. The first thing that I am going to do is I am going to say that in terms of writing this as a difference of two angles, my alpha is going to be the inverse tangent of 5/12. And my beta is going to be the inverse sine of -3/5. Okay, let's talk about these alphas and betas that we have, or this alpha, this beta that we have. Where does alpha live? I claim that we are privy to that information. She ran to the cafeteria to grab her phone. I also have drafts. Yeah. Sounds good. Okay, where does alpha live? Quadrant 1. How do we know that? Because the value here is positive. What are my two options for inverse tangent? Where can that angle live? 1 or 4. I live in 1 when my ratio is positive. I live in 4 when my ratio is negative. So absolutely correct. This is a quadrant 1 angle. Do we know what that angle is going to be? No, we don't know what angle goes with a tangent of 5/12. And we're okay with that. We actually won't even need to find the theta in this particular case. What about our beta? Where does our beta live? Sine inverse? Where's sine inverse? What is that? That is going to be the 4th quadrant, because sine is either going to spit us out in the 1st quadrant if it's a positive y value, or the 4th quadrant if it is a negative y value. That was the construction that we did for our inverse trig functions. Where would inverse cosine spit us out? Which two quadrants? 1 or 2, first or second. Very good. Okay. So we have cosine of now this alpha minus beta. What do I know about cosine? Cosine is nice, mean. Cosine separates the cosines from the sines, and to make matters even worse, it's going to switch that minus to a plus. And I could have written this as like cosine of tan inverse of 5/12 times cosine of sine inverse of -3/5. But again, that gets very, very overwhelming. I am trying to compartmentalize my information. I've set aside this whole notion of what alpha is, what beta is, and we're going to deal with those now in order to actually get something from that. What is maybe a way that I could rewrite that alpha is equal to tan inverse of 5/12? Think of this as kind of like what we did with exponentials versus logarithms. How could I rewrite this to make sense of what this is trying to tell me? What does tangent of alpha equal? 5/12. This is telling us the ratio that I would get when taking the tangent of this angle. So inverse tangent of 5/12 is the same as saying that tangent of this angle is 5/12. What information does that give me? Yeah, absolutely. This is my opposite and my adjacent. If this is alpha, then opposite is 5, adjacent is 12. What is my hypotenuse going to be? 13. If I didn't know that off the top of my head, what could I have done? Pythagorean theorem, 25 squared plus 12 squared. Sorry, not 25 squared. Good night. 5 squared plus 12 squared is equal to 13 squared. All right. And from beta being equal to sine inverse of -3/5, how can I reformat this statement into something that we can actually parse? Fantastic. And what does this tell me? Hypotenuse of 5, opposite of 3, and my adjacent side of 4. Very good. So that's all. That's all this inverse trig stuff is telling you. It's just telling you what the triangle looks like. And where it lives. Because notice, normally when I give you this kind of statement, that tangent of alpha equals 5/12, that's normally not enough information. Normally I have to tell you as well whether that theta is in quadrant 1 or quadrant 3. But that is actually implicitly built into my inverse trig function. It's nice and compact, and I just need to give you that inverse trig statement, and it communicates the triangle and the quadrant all in one go, which is really nice and convenient. All right, so what is cosine of alpha? (12/13). Is that going to be positive or negative? Positive, because alpha is in quadrant 1. Fantastic. What is cosine of beta? 4/5. Positive or negative? Positive, because beta is in quadrant 4. Yeah, fantastic. And our x value is positive in quadrant 4. All right, we are doing plus. What is sine of alpha? 5/13. Positive, because we're in quadrant 1. What is sine of beta? We actually already were given this one. -3/5. And so overall, we have 48/65 minus 15/65. You can box this. Like, this is perfectly fine. I'm okay with this as an answer. But this is also 33/65 as, a more simplified way to write it. It's a lot of information. A lot of information kind of very, very compactly presented. And so take the time to break apart that information. What am I being given? What am I being told about? First, looking at like just what is the outer shell telling me? I've got alpha minus beta. I've got two angles being subtracted from each other. Let's do my difference formula for cosine. Fantastic. Then I actually need to figure out, okay, what's going on with cosine of alpha, cosine of beta, so on. And then using the triangle definitions of trig in order to construct each of these. How's this feel? Hopefully a little bit more approachable than yesterday. All right, let's take a look at our bell work here. So number one, looking at tangent of 15 degrees. Do we know 15 degrees is that unit circle information that we're privy to? No, so we're not able to just kind of directly evaluate that. That's okay. How can I write 15 degrees as a sum or difference of two angles? Fantastic. Tangent of 45 degrees minus 30 degrees. Is that the only one that I can do? I could also do 60 minus 45. I should get the same answer either way. You should get the same result regardless. So we are looking at tangent of the difference of two. Tangent is nice on the top, mean on the bottom. That minus is going to stay a minus in my numerator. It's going to flip to a plus in my denominator. This is tangent of 45 degrees minus tangent of 30 degrees divided by 1 plus tangent of 45 degrees times tangent of 30 degrees. What is tangent of 45 degrees? That's just 1. What is tangent of 30 degrees? 1 over root 3. Or root 3 over 3. Either way is fine. I do not mind. And so we get that this is 1 minus 1 over root 3 over 1 plus 1 over root 3. Technically, this is one of those things that I said to clean up. I am okay. I've been saying that I'm okay if you leave it as is for this. This is fine. But if we were to clean it up, it would be changing the 1 that we see in both the numerator and the denominator, the 1 minus the 1 plus, into a root 3 over root 3 to match the denominators. And you can check me on this, end up with something like root 3 minus 1 over root 3 plus 1. But don't take my word for it. Double check it if you would. Yeah, it's fine. You can leave it like this. I do want you to actually like evaluate the trig functions, but I don't need you to do more than that. That's perfectly acceptable. Questions on example 1 here? All right, for 2, we are looking at cosine of 23 pi over 12. Not necessarily as easy to split apart as with the degrees. We could convert. I've been trying to give you methodologies that don't require you to convert from one to the other. I like us being able to handle radians as they are. What is my strategy with what we do when I'm giving you an angle in radians? Yeah, we're just going to set the first angle to be pi over 4. We want to find the second angle such that pi over 4 plus that second angle equals 23 pi over 12. And so subtracting pi over 4 from both sides, I get that beta should be 23 pi over 12 minus pi over 4. Now, to actually do out the subtraction, I need to match the denominators. So 23 pi over 12 minus 3 pi over 12, I get that this is 20 pi over 12, which simplifies to 5 pi over 3. All right. Cosine is nice or mean? Mean. So cosine groups all the cosines together and also is going to do shenanigans to that plus sign. So something like this. What is cosine of pi over 4? Root 2 over 2. 5 pi over 3 lives in what quadrant? Quadrant 4. So what is cosine of 5 pi over 3? Positive 1/2. What is sine of pi over 4? Root 2 over 2. And what is sine of 5 pi over 3? Negative root 3 over 2. I get that this is root 2 plus root 6 all over 4, but of course you do not need to simplify. This is also perfectly sufficient. Questions here with example 2. Yeah, done.
So the rate, when it's in ratings, before you solve it, like it is here, is it just would it be the difference if it was like a negative rating?
You could do this exact same process with negative ratings. You would get a negative value for beta. And the thing to remember is just if you have a negative value for beta, to use the difference formula rather than the sum formula. Negative beta, you would still plug in positive values in for alpha and beta, but negative beta just tells you to use difference instead of sum. If you're going to plug directly what you get for alpha and beta into alpha and beta, then use the sum formula. If you want to make the switch of if I see negative beta, then I'm going to plug in positive values into the difference formula, then that's also fine. Just don't plug negative values into the difference formula because that will undo what you are trying to do. But you could also, so I think the question here is, if we know that beta is going to end up being negative, could we set it up where it's a minus b is equal to this thing? Absolutely, you can. You'll end up with a positive beta, but you set it up to where you were looking for a positive beta that you were subtracting. That's also perfectly fine. Yeah, there's nothing wrong with that. Which I think was more the heart of your question. All right, and for number 3, looking at sine of tangent inverse first? No, cosine inverse first. Cosine inverse of negative 8 over 17 minus tangent inverse of negative 24 over 7. All right, this is my alpha, this is my beta. Where does alpha live? Second quadrant. Where does beta live? Fourth quadrant. All right. If alpha is equal to cosine inverse of negative 8/17, how can I rewrite this? Cosine of alpha, cosine of the angle, is equal to negative 8/17. If tangent inverse is equal to negative 24/7, how can I rewrite this? So I think I entirely said that wrong. If beta is equal to tangent inverse of negative 24/7, tangent of beta is equal to negative 24/7. And these are triangle problems again. What do I know about the triangle for alpha? Eight, 17. What's my missing side? Anyone know off the top of their heads? What is it? 15 is absolutely correct. But we could use the Pythagorean theorem in order to solve that if we weren't sure. For our second triangle here, this is beta. What do we know about this triangle? Opposite is 24. Adjacent is 7. Hypotenuse is 25, which again, Pythagorean theorem, if you were missing that. Sine is nice. Sine gets along well with our cosine. Sine's not going to do anything shady to the minus that we have in between our alpha and our beta. So should be equal to sine of alpha cosine of beta minus sine of beta cosine of alpha. What is sine of alpha? This is 15/17, positive or negative? Positive because we are in quadrant 2 and our y value is positive in quadrant 2. What is cosine of beta? 7/25, positive or negative? Positive as well. We are in quadrant 4 where our x value is positive. Fantastic. What is sine of beta? Of beta? Yeah, sine of beta. You can do cosine of alpha, sine of beta if you want to, and you get the same thing. I'm doing sine of beta, cosine of alpha. We'll end up with the same thing. So I get negative 24/25 because we are in quadrant 4. And cosine of alpha, we actually already know this one. Negative 8/17. And I am perfectly happy with boxing that answer. Questions with our work? Dr. Ballantyne? Yeah, she stopped by. Was she not out there? Okay, yeah. Yes, Sadie. Yeah, so this was from our thinking about the ranges of our inverse trig functions. So if I think about the range of, let's do inverse, well, let's do the two that we have here. If I think about the range of inverse cosine, what do I know about the range of my inverse cosine function? So you can think of it numerically, but here it's actually helpful to think of it in terms of the quadrants. So for sine and tangent, so for instance, sine and tangent, we see either if we get a negative y value or negative ratio, we'll be in quadrant 4, or if we get a positive y value, positive ratio, we'll end up in quadrant 1. So inverse sine, inverse tangent are always either going to be spitting out quadrant 1 angles or quadrant 4 angles, depending on whether the inside here is positive or negative. Here it's negative, so we see quadrant 4. For cosine, the kind of interval for our unit circle over which we are looking at cosine was quadrant 1 or quadrant 2. If the x value that we're looking at is negative, then we are in quadrant 2. If the x value that we're looking at is positive, then we are in quadrant 1. Was there a mathematical reason why we couldn't use quadrant 3 for the negative values of cosine? No, we just had to pick. And people who died a long time ago said that it would be quadrants 1 and 2. And so sine and tangent, you're right about the negative pi over 2 to pi over 2, but think of it as quadrant 1 or quadrant 4. It's kind of the nice way to think about it. Good question. Other questions with our bell work here? Hopefully a little bit more approachable than just looking at it and having absolutely no basis from which to work. Don't get intimidated by the inverse trig. Remember, it would be the exact same problem, the way it's formatted in the Pearson as well with the additional practice. If you are looking for more practice with these styles of problems, I put some pretty good ones in the 5.2 additional practice on Pearson. The way it's formatted there is they tell you to find like sine of alpha plus beta, where cosine of alpha is negative 8 over 17 for alpha in quadrant 3, and where tangent of beta is negative 24 over 7, where tangent or where beta is in quadrant 4. It's the same thing. I am just condensing that information into one line. So rather than giving you like 3 separate lines, 3 separate kind of pieces to this, I'm condensing, collapsing all that information into a single line. And then my advice is to treat that like a piecewise problem. Treat each part separately for the information that you are gaining here. First, deal with like, how does this decompose? Then deal with what are the actual angles trying to tell me? And then if you work through it very methodically like that, it should be a little bit easier. Yeah, done.
The sum and the difference of angles formulas. Or are we gonna have to remember?
Not on the quiz. Other questions? All right. So today's lesson, which you need the sheets for. Today and tomorrow. After Unit 5, we'll be back to the single packet, so we won't have all these loose papers floating around. So these are actually angles that we know. So √3/2 and 1 are actually unit circle values that we know. So try using that too. Like first, I would say find what angle this is referring to, find what angle this is referring to, and then that should make the problem like yes. I would not view out the numerator like that. Not that it's like wrong, just that it's going to be more difficult. I would focus on the denominator here. So you can do this. I would try instead. So notice that our final answer is all in terms of sine squared. So maybe try rewriting the numerator and denominator in terms of sine squared rather than in terms of the sine squared. Did everyone get a sheet? Okay. Okay, so today we are going to focus on the double angle identity. Tomorrow we'll do the half angle, but today we are going to do the double angle identities. The good news for us, okay, well, first we'll start with the bad news. The bad news for us, these are 3 additional formulas that you may need to memorize. The good news for us, though, is that they really aren't new formulas. They're just very, very corner cases, very, very niche cases for the identities that we have already studied. So, for instance, if I am looking at sine of 2 theta, we'll assume that I don't know what's going on with sine of 2 theta. All right, 2 theta is an angle, cloaked in enigma, no idea what on earth is going on there. But we'll also assume that I know something about theta, that I could use, that I could solve this if I could write things in terms of theta. How could I decompose this particular angle, 2 theta, into a sum or difference of angles that I already know? So another way to write sine of 2 theta. How could I rewrite that expression on the inside there? No, not able to bring that 2 to the outside. It's not a linear function. Which actually, I don't even know that would fit the bill for linear functions, but not able to just bring the 2 up. Yeah, absolutely. This is just sine of theta plus theta. This is a sum identity, but alpha and beta are the same angle. Okay, well, we could do that. That's not too bad. If this is alpha, if theta is alpha and theta is beta, sine is nice. Sine gets along well with cosine. Sine's not going to do anything to that plus. This should be sine of alpha, well, alpha is just theta, times cosine of beta, also theta, plus sine of beta times cosine of alpha, but it's all just theta, which is going to collapse into 2 times sine of theta, cosine of theta. So it's just like a very, very corner case, edge case of our sum property, but it's just our sum property or our sum identity, but the A and B, the alpha and beta, are the same angle. It's multiplication, so it hits both the sine and the cosine. It doesn't distribute, but it does hit both. We can do exact same logic to cosine and tangent as well. Cosine of 2 theta likewise is just cosine of theta plus theta, which is, well, cosine's mean, so cosine of alpha times cosine of beta minus sine of alpha times sine of beta. We get here cosine squared of theta minus sine squared of theta. And just our sum formula. And for tangent, tangent is nice in the numerator. It is mean in the denominator. This is going to be tangent of alpha plus tangent of beta divided by 1 minus, not 1 plus, tangent of alpha times tangent of beta, which we can collapse 2 times tangent of theta over 1 minus tangent squared of theta. Yeah. Quizzes tomorrow. Yeah.
How does sin theta cos theta plus like the sin theta equal only 2 sin theta plus cosine?
Yeah, so if you have trying to think of like a concrete example here. Think of the sine theta, cosine theta as kind of acting like a single variable there almost. It's like its own object. And we're asking like how many of these sine theta, cosine theta objects do we have that are being added together? And we have 2 of them that are being added together. So like think of like these as being like their own thing. And we have 2 of those particular things. Kind of.
Oh, so the 2 sine theta cosine theta is like one thing?
So we
That 2 sine theta times cosine.
It's 2 times sine theta cosine theta because we have 2, or we're adding the same thing, this sine theta cosine theta object to itself twice, basically. It's the repeated addition of something turning into multiplication. Yeah. And it's just the object looks a little weird. So to Nakaya's question of like, why don't we get 2 sine theta, 2 cosine theta? It's because they are, when they are lumped together with multiplication, kind of being treated like one object. Yeah. I think that's as good as I can get with that. All right, so let's take a look at example 1 here. So we are told that cosine of theta is equal to 8 over 17. And where does theta live? Theta lives in the 4th quadrant. Because we are between 3 pi over 2 and 2 pi, it's going to be a 4th quadrant angle. And we are trying to find sine of 2 theta. Now, do I know anything about 2 theta? No, we've got no idea what 2 theta is. We have no idea the y value that's attached to it. We don't even know what quadrant it lives in. It either lives in quadrant 3 or 4, but that's about as good as we're able to do. And I'm not going to go over how I know that because it's not important. We don't need to know anything about 2 theta to process this information. But in order to get away with not knowing anything about 2 theta, I need to restructure this, rewrite it in terms of angles that I actually know. Using my double angle identity here, this is 2 times sine of theta, cosine of theta. Now, I already know what cosine of theta is. Cosine of theta is just 8 over 17. How can I find sine of theta? What does cosine of theta being equal to 8 over 17 tell me? Adjacent is 8. Hypotenuse is 17. And what did we say is the opposite that goes alongside these ratios? A opposite side. And so what is sine of theta? 15 over 17, positive or negative? What quadrant of theta? We're in quadrant 4, where sine is negative. So a negative 15 over 17. And so our final answer, 2 times sine of theta times cosine of theta. You can leave it like this. This becomes negative 240 over 289. But leaving it as 2 times negative 15 over 17 times 8 over 17 is also perfectly acceptable. That is totally fine. Yeah, Dylan. What is the piece of information that it feels like we didn't use? I translated this. I didn't draw attention to it, though. Yeah.
Okay, so
Yeah. So theta is between 3 pi over 2 and 2 pi, which, if you look at the unit circle, puts us in quadrant 4. Yeah, between 270 and 360 is some kind of quadrant 4 angle. Yep. Yeah, so I used that. I didn't draw attention to it, though, so that's a fair question. Yeah, so using that kind of piece of where is theta, what values is theta, sandwiched between in order to figure out what quadrant we're living in, and then from there, just a matter of using the formula. Other questions? All right, take a stab at numbers 2 and 3. We'll take, call it 10 minutes-ish on those. First identify what quadrant you're living in. Then figuring out what that triangle is. So the two doesn't matter out. We could do sine of 2 theta over cosine of 2 theta and then use the formulas for both those. There's nothing wrong with that. It would get you the correct answer. But we also have a specialized one for it. It's a little bit more collapsed. But there wouldn't be anything like that. So that's cosine of theta or sine of 2 theta. So what part of it? Tangent is 1 over 1, right? And is it negative? Because it's negative y over negative x. Positive. It's both sine and cosine are negative tangent.
So, I know, sorry, you look at, I was just confused, because usually. But,
So that would be like if we were given inverse sine. So like if we were told that theta was equal to inverse sine of negative 1/3, then we would be in quadratic. The way that it's going to be given to you here, though, is that we're kind of given it into two pieces. We're given this statement, and then we are also given the constraint on theta. So we listen to this constraint on theta, not what it would be if we were to reconstruct it as. So all of your tangents will be positive because we learned in quadrant 3, which is independent of the inverse trig. That's just a
sine is.
Well, it happens. It turns out that sine is negative in quadrant 3 as well, and then cosine is negative there. So in this case, because it's not inverse trig, we take these two pieces of information kind of separately. And cosine is negative in quadrant 3.
So it's positive.
Yeah, so it's positive.
And then sine is.
So that makes sense. So this is that it makes sense that it would happen. It doesn't like do anything for it. It just like corroborates. Like, oh yeah, that would.
It's just, it's negative here because it is
a quadrant. 1 over 2. You substituted, yeah. So otherwise, otherwise.
Hello? So, this is really we don't.
I disagree with you. I think it looks like you do now. That's good. And you can clean it up by doing the multiply by reciprocal. Yeah, the 3's can cancel.
No, I was
that was good.
confused.
What
Why is it
then?
tangent?
Negative. Is tangent negative?
Oh, shit, no, yeah, you're right, you're right. No,
No, so these would be positive.
Don't know.
That's used for the 1.
It's because we're in quadrant 3 that that's the case. Well, okay, so if you were to, okay, how would we do? If you were to use the sine and the cosine would be -2, so it'd be -1/3 over negative root 8 over 3. Negative root 8, and the negative is what cancels, it gives us 2 positive, it gives us positives. Yep. I mean, you would plug into this, but yeah.
It's supposed to be positive.
Yes, because which quadrant are we in? 3, yeah, and tangent's positive in quadrant 3. Yeah, of course. Sorry, I had an unsimplified version of my mind, but yeah, that's good. All right, let's take a look at number 2 here. So we are told that sine of theta is -1/3. What quadrant does theta live in? 3rd quadrant. That. And we are trying to find tangent of 2 theta, which we know to be 2 times tangent of theta over 1 minus tangent squared of theta. So really the only thing that we are missing here is to figure out what tangent of theta is. How or what information do we know that can help us find that? Opposite side is 1, hypotenuse is 3, and therefore the adjacent side is square root of 8. And so what is tangent of theta? One over root 8. And is it positive or negative? Positive, because we are in quadrant 3, and negative y over negative x would give us a positive value. All right, so tangent of 2 theta is 2 times 1 over root 8 over 1 minus 1 over root 8 squared. You can box this. That is fine. We can clean it up a little bit, though. This is 2 over root 8 over 1 minus 1 over root 8 squared. 1 minus 1/8 is going to be 7/8. And multiplying by the reciprocal, I get that this is 16 over 7 root 8, which does simplify a little bit more, but this is great. All right. And for number 3, we are told that tangent of theta is negative root 7. Yeah. What part are you missing?
Just
Negative 7, negative root 7 over 5. What quadrant do we live in? This is quadrant. So theta lives in quadrant 2. So between pi over 2 and pi, between 90 and 180, quadrant 2. We're looking for cosine of 2 theta. Now, there are several formulae that you have on your sheet for cosine of 2 theta. Those are all what you would get when you substitute in like cosine squared, replace it with 1 minus sine squared, or replace the sine squared with 1 minus cosine squared. I'm going to stay consistent and use the one that we derived, which was that cosine squared minus sine squared is equal to cosine of 2 theta. So just for the sake of consistency, we're going to stick with this. All right, if tangent of theta is 7 over 5, negative 7 over 5, since we are in quadrant 2, what does that tell me about my triangle? Yep. And what is my hypotenuse? Square root of 32. Very good. And so what is cosine of theta? Positive or negative? For cosine? Negative for cosine. And sine is going to be root 7 over root 32, positive in quadrant. And so we end up with, notice here the positive negative doesn't really matter because we're going to square it, but still kind of worth going over how we would find those. This is going to be negative 5 over root 32 squared, that's 25 over 32, minus sine squared, that's 7 over 32. I get that this is 18 over 32 or 9 over 16, simplifying it a little bit. All of them are the same. Yeah, the other ones are just what you get when you replace like cosine squared with 1 minus sine squared or sine squared with 1 minus cosine squared. So they all end up working out to be the same. Yeah. I'm choosing, no, you're good. I'm choosing, it's a fair question. They all look very different. I'm choosing to use the one that came directly from our sum formula. So I'll use the cosine squared minus sine squared. But a lot of people prefer to use one of the other ones just because there's less to plug in, which is fine. And you should get the same result. Yeah. Yeah, of course. All right, questions about our double angle stuff? Yeah, Dylan.
Subtraction sign in there. Square root, because you don't do that. You plug. But I'm talking between the cosine squared minus the sine squared. You don't. It's always going to be subtraction no matter what, even though you squared it, because
Yeah, so we're going to be subtracting two positive numbers. So we're squaring first and then subtracting. And so whether the cosine or the sine are positive or negative is kind of a moot point. It gets lost in the fact that we square both of them. Yeah. Which is a little bit weird. And it kind of begs the question of like, okay, so then like, does the quadrant just not affect cosine of 2 theta? Or like, what's the deal then with cosine of 2 theta? What's determining whether it's positive or negative? And that is a fair question that I was sitting thinking through while you guys were working on these two questions. And I don't know the answer. It probably has something to do with like, I don't know. I'm sure I could work it out geometrically if I truly cared to. But yeah, it's a bit weird. It's a bit weird that the positive negative doesn't really affect much. Because we can make the observation, and this would be a fair observation, that what's really determining whether our cosine ends up being positive or negative is whether we are like closer to the y-axis or closer to the x-axis for cosine. If we are closer to the x-axis, then cosine squared is going to be larger than sine squared. If we are closer to the y-axis, then sine squared is going to be larger. So it probably has something to do with that geometrically, would be my guess. But it's a fair observation, and it's a good question. Other questions here? How are we feeling? Resounding good. Fantastic. Well, I only saw 1 thumbs up, so from my sample size, 2 thumbs up. This is getting stronger and stronger. 4 thumbs up. Stronger and stronger evidence by the second. Incredible. Good. All right, we'll stop our recording there. That is sufficient. Okay, so we've got about 20 minutes left. I had several people who reached